Question 1.4. The roots of a quadratic equation are x equals 3 plus minus rooted minus k minus 4, all on top of 2. For which values of k are the roots real? Now, before we begin this question, we must understand what they insinuate when they say real roots. Well, this is the form for the quadratic equation. This finds the roots for the expression of a quadratic. And when a quadratic has no real roots, that means that the parabola does not cut the x-axis. The roots are non-real. When they are real, they will at some point cut the x-axis. Now, there's a very neat trick to figure out if a quadratic formula for a given quadratic will have real roots or not. And that is by looking at the determinant. And that is the letters and numbers under the root sign. So what I mean by that is, if you want to find out if a quadratic is real or not for its roots, all we have to do is set up the quadratic formula for that quadratic and look at its determinant. If the determinant is bigger than 0, we will have real roots. If the determinant is smaller than 0, non-real roots. Sorry, that must be bigger or equal. So in order to answer this question, all we need to do is find out for what value of k must the determinant be that allows minus k minus 4 to be bigger or equal to 0, thus insinuating that this quadratic equation will have actual roots, real roots. So that's as simple as saying, all right, for what value of k, because this is the determinant, will the expression be bigger or equal to 0? Bring the 4 to the other side, divide the k by -1, swapping the signs, because when we divide by negative in an inequality, the signs, the inequality swaps, and we are finished. So we learn that in order for this quadratic equation to have real roots, so it cuts the x-axis, we need k to be smaller or equal to -4. And that is the problem solved.